Hello everyone, this is Samyak Goel and today I'll be presenting on the topic memory networks on which our team did the BTech project under Animesh Chaturvedi sir. So our group consisted of me, Dushyant Gupta and Vatsal Mishra. So let's start. So for the problem, we used question answering, reading and understanding a story and then answering questions about that particular story. Answering questions requires understanding the story, inference from sentences, chaining relevant sentences, induction, and deduction. So let's start with the introduction. So let us discuss why we use memory networks. So memory networks have a larger storage compared to other approaches which try to solve the same kind of question answering problems. Memory network uses an internal memory in order to remember the past. The long-term memory can be read and written and used to predict an answer for a given question. Output is textual response. Let us see an example now for how the story is and how are we questioning and answering. So, like there's a sentence, Mary moved to the bathroom. Then there's Sandra journey to the bedroom. Mary got the football there. John went to the kitchen. Mary went back to the kitchen. Mary went back to the garden. So a question could be, where is the football? So from third and sixth sentence, we can infer that the football is in the garden. So now let's start with the model. So memory network has four components. I component that consists of pre-processing of the input. The G component that is used for updating the internal memory. The O component finding relevant and necessary memory states given a question. And the R component that is used for predicting the final answer of the question using the output of the O component. So the I component, this component uses the bag of words approach to convert a sentence into an inner feature representation. Firstly, the dictionary is created by assigning a number beginning from 1 to each unseen word in the text. Now, the G component, this component adds the feature representation of a new sentence to the next available slot in the memory. In this case, the memory is presented at the beginning of each story, and in this way, the memory does not become huge and unrelated memory slots are removed. Now, let us look at the O component. So it scores the match between each sentence in the memory and the question. And this is the formula for the same. And it also calculates the probability of being related for memory states and returns the state with the highest probability. You can see the formula here. Now let us look at the R component. So the R component returns the final prediction of the model using the same method with O component. So this is the formula for that. Now look at what training we did. So these were the um, basic criteria that we used. So fully supervised learning was there. Soft loss was taken care of, and the knet.adam as a parameter optimizer were used. And reading text line by line, no mini batching was done. The training was done for 100 epochs. That is quite a lot of time. So let us see the experiments and result. So the data set that we took was of toy task data set of towards AI complete question answering, a set of prerequisite toy tasks, and it consisted of 20 different tasks. Now let us look at some of the results that we got. So for the task one, single supporting fact was there, and an example of such is also present. Now for the task two, the two supporting facts were present. You can pause and see the examples if you want. And now we can also see the graphs that we got for comparing accuracy and the performance. So the third task was three supporting facts. The fourth task was two argument relations, and you can see the respective graph for each of them for the performance. Now the next is the task 5, which consists of three argument relations. The sixth one was yes or no question. can pause and see the examples that are given. Also, you can see the graphs that we got for comparing the accuracies and performance of the model. Now, the task 7 was counting, and the task 8 was lists or sets. So now you can see the accuracies and the performance of a model. Now, the task 9 was simple negation, and the task 10 was indefinite knowledge. You can see the respective graphs for the accuracy. The task 11 was basic coreference, and task 12 was conjunction. So you can see the example also, and you can also see the graphs. Now, the task 13 was compound coreference, and task 14 was time reasoning. Like you can see the graphs here, both of them. And then we had basic deduction and then basic induction. And you can see the accuracies. Now that there comes positional reasoning and size reasoning. You can see the respective accuracies and also the examples if you wish. The task 19 was pathfinding and task 20 was agents motivations. You can also see the graphs here. So these were the accuracies that we got from a model, and thank you for listening.